Our last learning objective is to define the number e and apply exponential functions with a base of e. So right here it says many applications involve exponential functions with a base of e. The number e is an irrational number. The exponent function with the base e occurs frequently in biology and in finance. So what does e equal? E is another number like pi that we use frequently. So you can see that we have pi right here in our calculator. And we all know pi is about 3.14. Now, of course, pi never stops, right? So this is as many digits as we could program in the calculator, but pi keeps going forever and ever and ever infinitely. E is very similar. To get to E in our calculator, we will hit second and then divide. Okay, and you can see E is right here below our pi button. So if I hit second, divide, and hit enter, here's what what E roughly is. So I'm going to put 2.7183. But a lot of times we just call E 2.72 since that 8 will make that 1 go up. So roughly 2.72. Now we have another button for E. If you need just E by itself, this is the same as E to the first. We'll use second divide, but we do have another button right down here, E to the X. And so we can also get there that way too if we need to put an exponent, which a lot of times with E, we will need that. So to get E with an exponent, we will hit second and then ln. Okay, which is what we'll need for this right here. So example 10 says graph the function f of x on a window of this right here. So this is my x min and x max. And here is my y min and my y max. I'm not using zoom 0 because I have my y values as well. And then we'll answer the following questions. So let's go ahead and graph this. So punch that in. And because I need e to an exponent, I'm going to use this one right here. So second ln, which is right here. And you can see it brings e, and I already have that exponent position. So now I can put into the negative x. So now let's change our window. -5 to 5, a scale of 1 is good. And then -10 to 30. I'm going to do a scale of 5 for that one, but scales really aren't that important. And here is my graph. So part A wants us to find f of 1, f of -2, and f of 3, and we're going to round to 3 decimal places. So we will use trace, or you can use the table here. Okay, so you can use either one. When I have multiple, I kind of like using the table more. So I'm going to go second table. And here is f of 1 is 0.91. Ooh, okay. 97. That's 3 decimal places or 4 decimal places. If I want 3, here's my third one. That 7 makes this 9 go up, but that 9 has nowhere to go up. So now I'm looking at this as a 19. So that 19 is going to go up to 20. So either 9.2 or you can do 9.20. Those mean the same thing. F of -2, we have 18.473. That one rounds it for us. And f of 3 is 0.125. because that 5 makes that 4 go up. Okay, what is the horizontal asymptote? You can almost see it from this graph, how it's hugging that x-axis. But you can look at your table some more. These are getting closer and closer to 0 as these get to that e to the negative number. Okay, those all mean basically 0. So we have a horizontal asymptote at y equals 0, and I found that by looking at the table. And what is the y-intercept? Again, from that table, if we go up here to 0, it's 2.5. And when you're in that y-intercept, that means your x needs to be at 0.